Alright guys, we're about to do another probability question, and I'll just read it out first. A fruit bowl contains 3 oranges and 4 apples. Prue selects 2 pieces of fruit at random from the bowl. Use a tree diagram to determine the probability that Prue selects. 2 oranges, and B, an orange and an apple. Before I even look at this, A and B, I know that it wants me to draw up a tree diagram, and it's going to be for 2 pieces of fruit. So for these 2 pieces of fruit, for the tree diagram, you originally have 2 options. You're either going to end up with an orange or an apple, and they have different probabilities. While I'm at it, I'll continue on an apple, orange and apple. Now, if she's choosing them at random, which she does, and there are 3 oranges and 4 apples, she's more likely to pick apples on the first go. So down here, we might just write 4 out of 7 for the probability of picking an apple. Along the line of the orange, I'll write 3 out of 7 because there are fewer oranges. Now, looking after, so let's assume that she's picked 1 orange. What are the chances that she's going to pick another orange? Well, there are now only 2 oranges left. That's out of a total of 6 fruit. So that's 2 out of 6. When it comes to the amount of or the chances of her picking an apple, there are 4 apples left still, but now it's out of 6. If we go down the other row, if she picked an apple first, it's going to be 3 out of 6 for an orange, and 3 out of 6 for an apple. Okay, so we've used a tree diagram with probabilities attached. If we go down here, draw 2 lines and list the different probabilities, or different outcomes, sorry, we have a bit of a sample space. You can get two oranges, an orange and an apple then an orange, or an apple then an apple. So there are 4 different outcomes, and they are not equally likely in this case. Now, if I just grab this and shove it over here, I can start working on my answers. A. The probability of picking a double orange is equal to the probability of picking a first orange, which is 3 out of 7. And because we're going along the line of the tree diagram, we're going to be multiplying the probabilities together, so that's 3 over 7 times 2 out of 6. And I'll just get my calculator out to work that out. No need to stress yourself out. 3 over 7 times 2 over 6, and that's 1 out of 7. And there's your answer. For question B, it's a bit more complicated because we're working out the probability of picking an apple and an orange. We're not working out picking an orange then an apple, or an apple then an orange. We're working out the probability of picking an orange and an apple. And that means we're going to have to find out, well, that's going to be found by getting the probability of an orange then an apple and adding it with the probability of picking an apple then an orange. So, if I was to circle the 2 that this matters for, it's these 2, these mixed bunches. The probability that this takes place is going to be, so for the orange and an apple, it's going to be 3 over 7 times 4 over 6. And I'm going to add that probability to the probability of picking an apple then an orange, which is 4 over 7 times 3 over 6. And I need to get my calculator out and work that out. So 3 over 7 times 4 over 6. And I'm looking at my calculator so much that I haven't been writing it properly. 3 over 7, go press the crossways button, times 4 over 6, press the crossways button, plus our separate probability of 4 over 7 times 3 over 6. And that gives me a probability of 4 out of 7. And that's done.